so today we're going to continue on with the symmetry journey, and we're going to be asking what are some applications of it. So for example, let me say we're in a non-calculator exam, because if we had a calculator there's much easier ways we could solve these questions. But the question is, if I know that the sine of some angle is 0.342, then could I be able to, with some certainty, determine approximate values of sine of theta plus pi, or even theta plus 3 pi on 2? Alrighty, so let's have a think about it visually, what these different transformations are happening. So we've got theta plus pi, right? So let's just have a think about it. So let's imagine theta is a relatively small angle, right? Which is going to be around there. This is our theta. And I would like to draw theta plus pi. Well, pi would get us to here, plus theta is going to get me to around here. Now, sine is measuring the height, right? So it is this measurement here, this distance. And similarly, this one is also measuring the height, and so we can see that it'd be measuring somewhere around there. Now, from that, what can we say? Well, we can see that, right? In this quadrant, all sine, cos, and tan are all positive. In this one, only sine is, tan, and cos, meaning sine is not going to be positive in this section, but you can see that the distances should be approximately the same. Due to that, we must know that it must be 0.342, but negative because it's in the wrong quadrant. Let's have a look at the next one. So once again, let's leave our wonderful drawing of theta. This time we're doing theta plus 3 pi on 2. So 3 pi on 2 is all the way to here, plus theta. And now we've got an interesting dilemma, right? This sine coordinate here is the wrong bit in a way, right? You can actually kind of see that it doesn't quite match up. It's actually too long. For now we need to know this bit, but we only know how long it is this way. But that's fine, because if I know that the cos of the angle is 0.940, well, that's telling me how long the other side is. Remember, because cos and sine make up the x and the y coordinate. So by knowing the fact that the cos is equal to that, well, then I can just think, well, I'm not in the sine quadrant, which means that sine's going to be negative, and the value is going to be the same as what cos is. Without that cos, I would not be able to solve it. But now that I know what cos is, let's continue playing this game, except now playing with cos as our primary variable. So, drawing in my unit circle, drawing in my imaginary angle theta, which I still don't know what it is, but I'm just kind of making up for visualization purposes. Alrighty, and let's work out pi plus theta. So that's plus pi plus theta. And you can see there that the horizontal distance from here to here is the same as the horizontal distance from here to here, but all stations to central. Cos is not positive in this quadrant, meaning it's going to be negative, but it's the same distance, it's the same part of it, so it's still going to be 940. Alrighty, get rid of all of this, and let's try drawing this other angle, which is just negative theta. Well, actually, there's two ways we can solve it. One is knowing that negative theta is just equal to the cos of theta by one of our rules, and since we already know what the cos of theta is, it's 0.940. But visually speaking, negative theta would be approximately here. And you can see that the horizontal coordinates for both of these are exactly the same if this is negative theta. So we can quickly go, oh yes, that makes perfect sense, and cos is positive in that quadrant as well. Alrighty, so this is just a little bit of playing around with these symmetries and seeing what meaning we can actually come up with. I'll see you in the next one.